So before we go any further, I wanted to talk a little bit about the compilation process. So I mentioned before that this um, statements that start with a hashtag, like this hashtag include statement, um, these are preprocessor directives that get done before um, compilation happens. And when you um, start debugging, you get this little message, um, saying your project is out of date. Would you like to build it? So let me just talk a little bit about what that building consists of, and try to put this stuff in a picture. So I actually got this nice picture from um, this course, Introduction to C++. It's an MIT OpenCourseware course um, that has a lot of good stuff in it. It's well worth checking out. Um, but anyway, the way things work is we have these source files. So um, a source file would be, for example, your main .cpp here, and you could have more than one source file here. Okay, you could have multiple source files. So in the picture, we see two different source files. You could have, as I said, any number here. So what happens is the source file, if it has any preprocessor directives in it, will get processed. Those will be used to process it and put it in the form of processed code, which just means it's still in code form. It still looks like code, but it'll have more things added to it, or be manipulated somehow by these preprocessor directives. And then what happens is it compiles. Okay, so and the build process, when it says, do you want to build it, is basically we do the pre-processing, we get the process code, then we compile down to these object files, okay? And the object files basically are machine language, but they only have the instructions that come from the source file after it's been pre-processed. So it doesn't have any of the code that is written in any of the other files or in any of the libraries. So, for example, in C Sharp, you saw we had to use those DLLs, those dynamic link libraries, had to be added. So what needs to happen is the linker needs to take the object files and any of these pre-written libraries and put them all together into one executable file. And then that executable file can be run by the operating system as a program in memory. Okay, so that's the basic process. Other languages do things differently. In Java, everything gets compiled down to what they call bytecode, which is kind of like executable, except that it's not really. It's not all the way down to machine level. In Java, you have this Java virtual machine that actually takes this bytecode and translates it into machine-specific instructions. So, and that's the payoff there is that something that gets compiled down to bytecode can be run on, in theory at least, and depending on what you're writing, it'll sometimes work better than others. But in theory, you can compile Java bytecode down to Java bytecode and run that on a Java virtual machine on any system. If it's a Windows or Mac or a Linux or whatever. Okay, so the executables in C++, if you compile an executable on C++ on your Windows machine, you can't take that .exe file and run it on your Mac. There are also interpreted languages like Lisp, where you write the code and the code gets interpreted kind of on the fly, so that every time uh, you execute your code, you'll go through the whole process of, you know, bringing it down to machine level and running it. And actually, that can be convenient for debugging purposes and things like that. So there are trade-offs in this process, basically, is what I'm saying. And the trade-off for C++ is really speed. Um, in general, a well-written C++ program will outperform a well-written Java program, or certainly from any interpreted language like Lisp or anything. So that's the general process. Okay, so I mentioned earlier that in addition to this cout, there's a for printing out to the console, there's a cin where you can read in from the console. So I'm going to give an example that shows how you can use cin to load a value into a variable. All right, so let's create a new project here. I'll call it in and out. And let's see, I'll create a new C++ file, main.cpp, and we'll put in our preprocessor directive here, our include iostream, because we need some stuff from there, and we're going to put in using namespace std, so we can skip putting std : in front of our cin and cout. I'm going to say int main, because remember in C++ the main function returns an int, and I'll make a variable x. So this looks a lot like the way we make variables in C#, right? And then I'm going to say cin, and whatever I get from cin, I'm going to pipe that into my x value. Okay, so notice the direction of the angle brackets here for cin, because we're going from the console into, whatever we get from the console, we're piping that into the variable x. Whereas with cout, what we're doing is we're taking the value from, like say, x divided by 3, and piping that out to cout. And then I'll also do let's do another one. Let's do x times 2. All right. And I'll stick an end on there. And do a system pause. All right. And return 0. Okay, there's a similar example to this in that MIT course I was telling you about in the last video. But so now I don't see any squiggly lines, so maybe we can get it to work here. Let's see. This project is out of date. Would you like to rebuild it? Yes. Okay, so now I just have a blinking cursor. So that's basically saying I'm ready for my input. So I'm going to press a 9 here and press enter. And it gave me a 3, which is 9 divided by 3, and an 18, which is 9 times 2. And the system pause said press any key to continue. So I'm just going to press a space bar, and I'm done.